Greetings to all. The session is regarding chemistry content. It will be provided on the intermediate examination strata, which will be fetching for your international entrance and competitive exams as well. If you're aspiring for JE Advanced, JE Mains, Neet chemistry in all India level in order to get the admission into IIT, NIT, and also into the medical stream. So this kind of session will be helpful. Telangana and Andhra Pradesh government are conducting Eamcet examination for BTech admission. In addition, various government organizations, state level, national level, are conducting competitive exams to get government job opportunities. There, a general studies common question paper will be there. In that, general science content will be there. The session we are discussing is very much helpful for your preparation. Let's go with our today's content. The question is regarding these coordination compounds, where coordination complex is provided, explain the primary and secondary valency of the following complex. This is the coordination complex. In the entire intermediate chemistry, coordination complex have the highest weightage for any kind of exam that may be entrance or else any competitive exam, highest provision for the highest weightage for the question framing analogy, right? Here, primary and secondary valency of the following compound to be identified. The complex is chromium H2O taken 6Cl3. It is the chromium hexaaqua complex. You can notice inside 6 water molecules, outside 3 chlorides are present. If you observe, this is the way complex can be represented, where central chromium are surrounded with the 6 ligands of water, aqua water molecules will be there, and outside Cl3 can be written as a +3. This is the way complex is represented. In this, how can you identify primary and secondary valency? In order to answer this, the given complex is cationic. If you remove chlorides, it will become cationic complex. The central metal atom chromium is in a +3 oxidation state. So in order to counterbalance this +3, counterbalance the 3 negative charges by this chloride, so here chromium is acquiring +3 charge. So whenever chromium is acquiring +3 charge, so what happens? This whatever charge acquired due to the ionizable ligands, that corresponds to the primary valency. Hence, we can say primary valency of any central metal in the coordination complex is equal to its oxidation state around that central metal. The oxidation state corresponds to these ions whichever present over here, right? So this is a +3 oxidation state around the central chromium, so that its a primary valency is 3 itself. Now move on to secondary valency. So secondary valency, central metal atom is bounded to 6 water molecules, and hence its a secondary valency is said to be 6. So being number of ligands which is surrounding inside the sphere of the square bracket, which is said to be its a secondary valency. 1, 2, 3, 4, 5, 6, 6 water molecules are there in order to contribute electrons to the chromium, so that 6 is the secondary valency, and the chromium is accorded with the +3 oxidation state, so that the whatever oxidation number is there, that equals to its primary valency. This is the way primary valency is said to be 3, secondary valency is said to be 6. This is the way the question can be answered. This complex name is accorded in accordance with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. Let me give the name of the compound, hexaquochromium 3 chloride. Let me repeat, hexaquochromium 3 chloride is the IUPAC name of the compound, and primary and secondary valence will be accorded in such a manner. Move on to question. Here you can clearly notice chromium hexaco complex is there. Inside the sphere, you can find a secondary valency. Outside the sphere, whatever charge mentioned is the primary valency for the given complex. Move on to question number 2. Question number 2 collected from Cambridge Assessment International Education. So from this, the question was taken, element X can undergo following physical changes. These are the changes you can notice. Solid can be converted into a liquid one, liquid can be converted into a gaseous one. So if this is the case, then name each of the numbered physical changes that are possible. If solid turned into a liquid, what change you can say, what term you can mention over here. Scientific terminology in specific, chemical terminology will be there in order to assign this solid to liquid transformation and liquid to solid transformation as well. Liquid can be converted into gaseous form, gas can be back converted into a liquid one as well. This is the way phase changes you can notice that can be given by whenever solid, for example, I'm taking ice, this ice cube upon liquefaction, you can go with the melting. The process is said to be melting. Any solid turned into a liquid is said to be a melting. So liquid, if converted into a gaseous compound, that is said to be vaporization. And if liquid converted into a solid one, that means a back conversion. You can say freezing, you are freezing to a solid one. So if you're turning the gaseous component into a liquid one, called condensation, right? So this is the way you can represent all the phase changes in a triangular form. Let me give the brief introduction over there. Solid converted into liquid is called a melting. Liquid converted into solid is called a freezing. Liquid converted into a gaseous compound called evaporation. Gaseous compound converted into a liquid one is called condensation. Gas converted into solid called deposition. So solid converted into a gaseous one called a sublimation. This is the way all the triangular transformations are possible and which are mentioned, the best represented in a triangular form. All questions got answered, whatever solid, liquid, gaseous components are transforming one phase to another, like, right? Move on to question number 3. This is collected from JEE Advanced 2017 question paper, paper 1 question, please. The sum of number of lone pair of electrons on each central atom in the following species is tellurium bromide, tellurium hexabromide -2 anion, and bromine difluoride cation, sulfur nitrogen trifluoride, xenon trifluoride anion. So if these are the complexes provided to you, tellurium, bromine, sulfur, and xenon complexes are given to you. The question is sum of total number of lone pair of electrons on each complex to be identified. For our convenience, the data is provided. Nitrogen atomic number is given as 7, fluorine is 9, sulfur is 16, bromine is 35, tellurium is 52, xenon is 54. If these are the atomic numbers, you can go for their number of lone pair of electrons. So the answer is expected to be drawn as a 6. We have to go for how to calculate this 6. In order to answer that one, there are the species provided. If you go with the tellurium, tellurium is the metal which is accompanied by the atomic number 52 just above the xenon, so that you can find the NS2 NP4 electronic configuration. NS2 NP4, because the two electrons are short with respect to xenon. Xenon is the noble gas, no? So that if you remove two electrons from this xenon, that will become a tellurium. Okay. Around the tellurium, how many bromines are there? 6 bromines are there. You can accommodate all 6 bromines over here. Whenever 6 bromines are accommodated, one lone pair is also accompanied with the tellurium, so that one lone pair is present over here, right? And if you go for second compound, bromine difluoride, positive one. When bromine difluoride is taken, this is a kind of angular arrangement, just like a water molecule. Bromine is atomic number 35. Atomic number 35, whenever two bonds are generated, and being it is a kind of sp3 hybridization, and two non-bonded electrons are present over, two bonded electrons, two non-bonded electrons, two pairs of non-bonded electrons you can notice, so that we can say here number of lone pair of electrons are 2. And move on to this xenon trifluoride. They are saying about xenon trifluoride, right? Its atomic number is 54, completely filled noble gas configuration is accorded. And you can notice whenever 3 fluorides are there, they are accompanied with the 3 bond paired, 3 lone pair of electrons over here, and it existing in a octahedral geometry, and 3 are located at one side and 3 lone pair of electrons in another side, so that here possible lone pair of electrons and xenon trifluoride are 3. Move on to another. sulfur nitrogen fluoride. It is not stannum. Rather, it is the kind of sulfur nitrogen trifluoride. Always nitrogen able to form triple bond over there, so that you can find a triple bond with the sulfur atom, and you can find more three bonds with the three fluorine atoms. This is the case you can find for sulfur. If this is the kind of bonding, all the electrons and the outermost shell got consumed for the bond formations, and no lone pair of electrons found over here. If you go with tellurium hexabromide complex, it can be accompanied by one lone pair, so that let me mention only one. Then bromine difluoride angular complex is having two lone pair of electrons. It is mentioned with two. Whenever you can go with the SN F3, where you can't find any lone pair on the central sulfur atom, so that it will be a zero. Xenon trifluoride is having three bonded and three lone pair of electrons. It is taken as three. So this is the way all the lone pair of electrons are mentioned for different complexes. And if you go for adding all this, because they are asking for total number of lone pair of electrons from all these complexes. 1 plus 2 plus 3. Total 6 lone pair of electrons are possible. 6 lone pair of electrons are mentioned for this question. For question number 3, our correct answer is 6. Move on to question number 4. Question number 4 is also collected from JEE Advanced 2017. Paper 1 question paper. A crystalline solid of pure substance has a face-centered cubic structure with the cell edge of 400 picometers. If the density of the substance in the crystal is 8 grams per centimeter cube, then number of atoms present in 256 grams of the crystal is n into 10 to the power 24. What is the value of n to be identified? The question given from solid state chemistry, where different lattice forms will be there. Among face-centered cubic was taken. So for this face-centered cubic, the number of atoms present in the crystal, the number of atoms present in the 256 grams of crystal to be identified. Half of the answer is given, remaining half to be identified. That in value is calculated as 2. We have to go for how to calculate this one. Here, they said about the compound, the solid existing in a face-centered cubic structure. Face-centered cubic, all the atoms are identical. Face-centered atoms are shaded. So face-centered atoms are located in such a manner. All the corners are occupied by the atoms, and each face is also accompanied by the atoms, and at the center, one more atom will be there. Coordination number accorded for face-centered cubic lattice will be 12, and face-centered cubic lattice cell, 6 phases, each phase contributing 1 by 2. Each phase contributing 1 by 2 atoms, and you can find 8 corners. Each corner contribute 1 by 8. If you go for 1 by 8, what happens? So here cancellation 8, 8 is a 1 only. Here you can get only 1. And 2, 3 is a 6. So 3 plus 1, that will be 4. So face-centered cubic structure contribute 4 atoms per the lattice. FCC lattice, 4 atoms will be denoted. There is a formula in order to calculate that kind of, they are asking for what is the amount, right? So at that condition, in order to calculate that one, density is equal to Z into M by Na into A cube. Let me elaborate all the terms which were present in the formula, and this is applicable to FCC lattice only. This density formula is applicable to FCC lattice. D for density. So D indicates it is the density, and the Z, whatever mentioned, number of atoms present in the FCC. Just now we calculated number of atoms are 4. Each phase contributing half, each corner contributing 1 by 8. Phases are 6 and corners are 8. Total 4 atoms are contributed for FCC. And M denotes molar mass of the given FCC lattice solid form. Na means Avogadro number, that is fixed 6.022 into 10 to the power 23. A is the cell edge. A cube can be taken. Whatever cell edge data is provided, that can be powered 3. Okay, so this is the formula. They mentioned that the density of the solid is given as 8 grams cubic centimeter inverse. So let me mention 8 for density, and Z means number of atoms. For FCC, it will be 4. Just now we gone with the calculation. M is the mass of that one. Molar mass to be taken, that is unknown. Avogadro number is already known term, that is 6.022 into 10 to the power 23. And here you have A, that is cell edge 400 picometers can be converted into meters by multiplying with 10 to the power negative 10. And being it is the power 3, so that whole cube can be taken like this. M is given as a 76.8 gram per mole. 76 grams contains 6 into 10 to the power 23 atoms. So that you can write it as 256 grams contains how many atoms? So here we have within the given compound 256 grams of crystal is there. Okay, 256 grams of crystal is there. If 76.8 grams contains 6 into 10 to the power 23, this is the standard one. 256 grams if provided, then what is the number of atoms? This is the way you can go for cross multiplication. 256 into 6 into 10 to the power 23 by 76.8. That is calculated as 20 into 10 to the power 23 atoms. Okay, but within the problem they mentioned, so they what logically mentioned 10 to the power 24. If you want to get the same powered value over here, let's take this 0 this side. So you can write it as a 2 into 10 to the power 24. That way also you can write it. Here 10 decimal can be converted into 2 decimal by multiplying with 10 to the power 24. So that 2 into 10 to the power 24 you can write it. Whenever 2 into 10 to the power 24 atoms are present, 2 into 10 to the power 24 already given within the problem. Only required value is 2. N is equal to 2 can be calculated like this. N is equal to 2 can be calculated. This is the way question can be answered. Move on to another question which is collected from Eamcet examination conducted in the year 2020. Identify the law of which of the following statements equal volume of all gases at the temperature and pressure should contain equal number of molecules. Let me repeat the question. Equal volume of all gases at the same temperature and pressure should contain equal number of molecules. Temperature, pressure kept constant. If the volume taken as a equal for all the gases, then they contain same number of molecules. ఒకే పీడన ఉష్ణోగ్రతల వద్ద సమాన ఘనపరిమాణం గల వాయువులు సమాన అణువులను కలిగి ఉంటాయి. ఈ సూత్రాన్ని ఏది సరిగా వివరిస్తుందో చెప్పండి. గెలుజాక్స్ లా or else Avogadro's law of multiple proportions, law of conservation of mass. Okay, so among all, here Avogadro's law is the correct answer regarding this. Equal volume of the gases contains equal number of molecules at constant temperature and pressure. True for any gas. This can be applicable to any gas. Temperature, pressure kept constant, then equal volumes of gases contains equal number of molecules. This is the answer you can get. Move on to another question. This will be the last question of the session. A gas is present at pressure of 2 atmosphere. What should be the increase in the pressure so that the volume of the gas can be decreased to 1/4 of the initial volume? Pressure and volume are inversely proportional. As we rise the pressure, volume will be concised, because by applying the force, what happens, all the molecules got concised, no, so that pressure and volume always inversely proportional to each other at the constant temperature. ఒక వాయువు 2 అట్మాస్ఫియర్ల పీడనం వద్ద ఉన్నది. దాని ఘనపరిమాణాన్ని స్థిర ఉష్ణోగ్రత వద్ద తొలి ఘనపరిమాణంలో 1/4 వంతుకు తగ్గించినప్పుడు పీడనంలో పెరుగుదల ఎంత? మనం ఘనపరిమాణాన్ని తగ్గించినాం కాబట్టి కంపల్సరీగా పీడనం అనేది పెరుగుతుంది. దేర్ ఇస్ ఎ ఇన్వర్స్ ప్రపోర్షనాలిటీ బిట్వీన్ ద ప్రెషర్ అండ్ ద వాల్యూమ్. How much pressure to be raised in order to make the given gas into 1/4 of initial volume, right? So the correct answer is expected as 8 atmospheres. How to get this answer? We will go for the calculation. If the temperature is maintained constant, according to Boyle's law, pressure and volume is equal to the product of pressure and volume is constant. Mass for the given mass. P is the pressure, V is the volume. Then we can go for if two different conditions are provided, P1 V1 is equal to P2 V2 can be calculated. So here the gas is given at 2 atmospheric pressure, that is taken as P1, and the volume of gas is taken as V meter cube. V2 is concise to whatever volume is there, in that it will become V by 4 meter cube, so that it will be concise to 1 by 4th, no, so that V by 4 concised volume you can notice. Let me apply all these values in the equation. Pressure volume is equal to P2 V2. Then initial pressure is 2, so that let me mention 2. V1 is taken as V, 2 into V is equal to P2 is not known. P2 to be calculated into V2 value is V by 4. Okay. Left side volume is there, right side volume is there. Let me compensate each other. Both get cancelled out. Then 2 is there in the numerator, 2 is there in the denominator. If you take this 4 to the left hand side, what happens? 4, if it is going to left hand side, it will become a numerator. So that 2 multiplied with 4 will become 8 atmospheres. The pressure, the final pressure will be 8 atmospheres. This is the way you can go for the calculation. 8 atmospheres is the correct answer. Okay, initial pressure is 2 atmospheres. Initial volume taken as B. After rising the pressure, that is P2, volume decreased to 1 by 4th. V by 4 volume got decreased. So that if you apply the formula P1 V1 is equal to P2 V2, so that you can achieve the answer 8 atmospheric pressure. This is the way question can be answered. The entire derivation part is also provided. Hopefully it is clear to each and everyone who are watching over here. And we covered with the various content regarding the chemistry related with the intermediate sector, and different dimensions got covered over here. We gone through the IUPAC nomenclature, coordination complexes taken into the consideration, gaseous laws mentioned over here, and organic chemistry also the part of this one. Hence this is really informative, and definitely I will assure for your success in the examinations, either that may be JE Advanced, JE Mains, NEET Chemistry, or else Eamcet examination, or else you are preparing for any competitive exam. Definitely this will be fetching for your preparation, and it will add your weightage to the increasing your score. Hence, I'm sincerely requesting to like the channel, comment. In order to comment, we have a question over here. You can give the definition for Gay-Lussac. So kindly give the definition for Gay-Lussac in the comment section, so that we will go through that and share with these parents who are serious about the preparation, and subscribe the channel. We will go with the new content in the near future that will be fetching for your examination point of view. Thank you very much. Always increase your enthusiasm to learn something new, so that we will achieve so many things in the near future. Thank you very much.